Professor Jim Schultz here from my Finance 680 students. I wanted to take a few minutes here and shoot a video for number 52 from Chapter 6. This is a very challenging problem, definitely something that I would rank in the difficult genre of the types of problems that you could see on our first exam. And so I think it's worthwhile to go ahead and go through this this problem here in this video. So in this problem, you have a 5-year annuity, which is going to be 10 $8,000 semi-annual payments. The first payment is 9.5 years from now, so this annuity does not occur until the future. You have an 8% interest rate that is compounded monthly, which is what you find right here. Okay, so as is the case with most time value money problems, my suggestion is first and foremost, go ahead and construct a timeline. So here's your timeline basically. Here's now. You've got the first $8,000 payment coming 9.5 periods from now, and then you have 10 payments total. So it goes from 9.5 all the way to 14. That is the entirety of your annuity. Okay? So that's a critical first step. The next step, and in my opinion as we scroll down a little bit, the next step is the absolute core of the problem. This is what you have to have a firm handle on to be able to solve this problem correctly. Alright, so if you look at the problem, you notice you have monthly compounding. So the first condition for needing an EAR is met, non-annual compounding. You also have monthly compounding paired with semi-annual payments. So the compounding frequency and the payment frequency are not equal. That is the second condition. Therefore, you do need an EAR for this problem. So that is where we are headed next. Alright? Now, when you have a complicated problem like this, where you have non-annual compounding with a compounding frequency that's not equal to a payment frequency, and neither of them are annual, here's basically how you want to solve that situation. What you basically need to figure out is, I need a semi-annual interest rate to match my semi-annual payments, but that semi-annual interest rate must include monthly compounding. So you have kind of a tall order on your hands. You need a semi-annual rate that accounts for monthly compounding. So basically the way to do that is in a two-step process. Here's the first step, here's the second step. So here's the first step. The first step is simply take the interest rate you were given and find the EAR based on the compounding frequency that you were given, which in this case is monthly. So all I'm going to do is I'm going to take 8% and I'm going to compound that guy monthly and figure out what its EAR is. That is the 8.3%. That 8.3% is an annual rate that accounts for monthly compounding. Alright, so once we have that in place, what you're going to do next is utilize this same equation, but you're going to do it in a different way. You're going to keep your EAR fixed at 8.3%, but now you want to solve for the semi-annual rate that fits that monthly compounded EAR. So you have to use the EAR equation again. You can't just divide that by 2. You must use the EAR relationship because you're still operating within the EAR framework. So that is where you see this second equation or this second iteration of the EAR idea come out. APR divided by 2 is basically your effective semi-annual rate based on monthly compounding. It's basically your semi-annual rate that you need for this problem while taking into account monthly compounding. So you work through the algebra and you get down to a semi-annual rate of 4.07%. So that is the interest rate that you're going to use for this problem. Next, and in my opinion, once you've gotten through that part, the rest of this is pretty straightforward. You now need to figure out, the problem originally asked us for what is the value of this annuity in 5 years, in 3 years, and now. Okay, so the first thing you want to do is you want to figure out what is the present value of the annuity when the annuity begins. That present value was found to be $64,661.64, and that was found by taking standard annuity valuation procedure. Future value 0, your semi-annual interest rate, your semi-annual payment, that should say 8,000, not 7,000, and then 10 payments. Present value, boom, right there. Where does that go on the timeline? Well, that belongs at period 9 on the timeline, because just as with any annuity, the present value of any annuity is always going to be one period before the first payment is paid. And if that's confusing to you, think back to some of the simple examples that we did in class. Like when I asked you to find what is the present value of a 3-year annuity, right? What is the present value today? If you can visualize that timeline, you have 0, 1, 2, 3. And 1, 2, 3 all have $100 on them. When I ask you to find the present value of that annuity, the number that you find goes at period 0. Or in other words, one period before the first payment is actually paid. So we actually have, oh, hang on a second. No, I don't want to do this. I'm going to X that out. Alright, so sorry about that. Hopefully we can power through here. So the first payment is at 9.5. Its present value goes at 9. So that is why this number belongs at period 9 on the timeline. And then after that, the rest of these numbers are basically just found using that as your reference point. If that is at period 9, 5 years from now, or 5 years from 0, would be 4 years before that annuity begins. So its future value is what we found here. I is the same. There's no payment. You've already included the annuity payments into this number right here, so you don't need to include them again. We're bringing this back 4 years, which is 8 semi-annual periods. So you get a value of $46,993.99. And then 3 years from now would obviously be 6 years before the annuity begins, because again the annuity begins at period 9. So period 3 would be 6 years before period 9. Future value is the same, I is the same, payment's the same, the end now is 12. 6 years has 12 semi-annual periods. You find the present value at $40,062.69, and then the current value is simply found by bringing that guy all the way back to present day. So n is 18. You get $31,534. Looks like 56. Let's go with 56. $31,534.56. So this is how to solve problem number 52. I hope this was helpful for you guys.